When we start looking at phase angle, or we call phase shift, we're actually taking two signals, one input and one output, and we're comparing it to each other. Say that we have one is our input and number two is our output. So we can say that number two is leading number one. So when you're actually setting these up on the oscilloscope, we have to make sure that we know which ones are input and which ones are output. The best answer to that question is, which one would you use? Channel 1 should be always your input, and channel 2 should be always your output. So let's say we have two sinusoidal waveforms, and we'll be creating these in the lab using capacitors and inductors. And what we're going to be doing is doing similar measurements of phase angle. The nice thing is that our oscilloscopes do these measurements for us automatically. We can actually set up the oscilloscope to measure it using a special method. There's number two way, and number three is doing the old-fashioned math method. I'm just going to show you the old-fashioned math method right here. So basically, the old-fashioned math method here, basically what you're doing on this is you're taking TD. Remember, this is time. T isn't time. So you're taking the distance between these two waveforms, and you're comparing it to the full cycle of your input on channel number one here. So if we look at this, here's the equation. So what we have here is 360 degrees. Well, it's 360 degrees times by TD over time, over the time of one cycle. So we're taking the time between these two, the difference between these two right here, the time between these two, and then we're dividing it or putting the ratio over T. So that's phase angle. We will get to this a little bit more in later on in the chapter, but that pretty much explains AC basics. And I know that we're going to get into real and average power later on, but at least we'll be able to have an idea of what you're dealing with, how to come up with some of these measurements, and fully understand what, when somebody actually says, hey, find peak to peak, what's the phase difference, what's the phase angle. Now, before I close that out, and I just really thought about something, this phase angle or phase shift is probably very vital. So you probably ask yourself, where would I see this in real world applications? Well, yeah, capacitors, inductors, and all that, and communication circuits, you see that. But in reality, too, is when you're actually using, taking wind turbines, and you have an AC voltage there, it's going to have some sort of phase shift to the voltage that we have coming up from the power plant. We just can't take that AC voltage coming off the wind turbine and throw it to our grid. We need to match it, because if we did it, it would blow up in front of us. So that would be a good example. So what we would do is you would have some sort of special circuitry that would actually align the two and make sure that they're not going to go out of phase with each other. Because, like I said, it could be a big issue when you're looking at voltages on both the turbine as well as in the power plant. So thank you.